Introduce you. Hi, everyone. Thanks for coming for one of the last sessions. This is the second last session today for Quantum Discovery Day. And we have Megan Lee, who's going to be talking about Quantum City and its program. And so I'm going to hand over the mic to her. Thank you for coming, Megan.
Of course. Thank you. Oh, thank you. Thank you, David. Yeah. Thank you, David. Okay. Hi. My name is Megan. I'm from Quantum City. I know many of you have heard about quantum science and quantum technology throughout the day. And you may be wondering, okay, so I'm interested, now what? Like, how do I get my quantum journey started? So I want to talk about our initiative and the programs we have available for you as a resource. I'm not a quantum scientist. I'm a scientist, but not quantum scientist, so this is not going to be a real technical talk. So, all right. So we started about 2 years ago as a strategic initiative between University of Calgary and the government of Alberta, and our first anchor industry partner Emphasis. And our vision is to become a global quantum solutions hub where quantum tech becomes quantum solutions. So when we started about 2 years ago, we did sort of an environment scan. And so we're one of the 4 quantum hubs in Canada, for example, and there are quantum hubs around the world. But we really felt that gap in the ecosystems was on the quantum adoption side. So many hubs focus on pushing the IP out of the lab into startups, hoping some of them will turn into unicorn. I'm sure some of them will. But if you ask a startup, what's the biggest worry? It's the first customer, the revenue-generating customer. Grant is great, but that's not revenue. They're looking for their first customer. So what we're hoping to do is, create the customer base. So essentially help the potential adopters and users of quantum solutions and create that market pull. So under this vision, our mission now is to capture the benefit of quantum tech by creating adoption pathways. Quantum City is here now building an ecosystem for quantum science technology in Alberta, bringing together researchers and developers in industry and adopters of quantum tech and science services. So we have 3 strategic pillars of activities. First one is establishing and operating enabling infrastructure in quantum. Second, we're creating a pipeline for talent and experts. And third, we're narrowing the gap between quantum tech and quantum solutions to support the development of a vibrant quantum economy here in Alberta. So for the infrastructure side, QHub and QLab are our 2 major initiatives we have going on right now. So QHub is a collision space for quantum researchers, users, and creators. And programs will be available within QHub, which include startup incubation, knowledge center, and a membership program, amongst many others. And QLab is in current development, and it will be located within the QHub. So QHub will host clean room spaces, advanced fabrication tools, and characterization services to serve both research and industry. So these buildings are actually in University Innovation Quarters, so just north of the U of C main campus. And QHub will actually open very soon. So we're looking at February or March of 2025. And it's about 17,000 square foot collision space that will support, of course, central Quantum City activities with offices and meeting rooms and event spaces, hot desks and labs and workstations. And the architectural design considerations were, of course, for promoting the interactions between quantum creators and quantum users, such as collision spaces, Blackboard integration everywhere. Apparently physicists don't work on a whiteboard, they insist on Blackboard. So Blackboard everywhere, and a cafe bistro. And right next to the QHub will be QLab North. So we have QLab North and South, but North is the main location. So this is a clean room facility with 3,800 square foot of space, and this will be the cleanest semiconductor space in Alberta, essentially. So it's an open user facility to promote industry engagement, basic science and R&D, and prototype development, and it'll house all these state-of-the-art tools that I mentioned here for quantum device makers. Okay, so now moving on to the industry engagement side. So, we heard quite often from the industry, okay, Megan, you sold me. I'm interested in quantum, but how do I get started? I have no in-house capability. How do I even get started? So based on that demand, we created this program, Scientist Residence Program. So many of you might have heard from our first SIR in quantum algorithm, Dr. Adam Benny-Watts, sitting right here, and beautiful orange fall color here. So I would say, think of these SIR as the world-class researchers that are available as your guide in your quantum adoption journey. So they'll bridge that gap between academia and industry. So depending on whether you're a quantum creator or user, the mode of interaction will be a little different. So for the quantum creator, the SIRs will be available for secondment, so that could work with you within your company for a short-term period of time. But if you're a quantum solution adopter, that can be your guide in your quantum adoption journey, whether you're just looking at, hey, I know nothing about quantum, can we just do a sort of a educational discovery workshop, to an actual, full-on engagement, that sort of an R&D project that involves, of course, SIR, but faculty, researchers from University of Calgary or kind of from around the world where we have connections with, and that could, engage interns that are, studying on campus here, or your current workforce for reskilling and upskilling opportunities. So Quantum City Challenge was probably our most public event or initiative that we did in industry engagement side. So it was a global quantum tech competition that started in 2023 and ended in 2024. And we essentially challenged the experts and enthusiasts from around the world to solve Alberta energy industry problems using quantum knowledge. So it was made possible by Quantum City, AWS, and the government of Alberta, of course, and the University of Calgary, our two biggest supporters. And the competition focused on 3 problem statements from 2 companies that you know of, ACCO and Canadian Natural. So ACCO gave us a problem statement on EV charging optimization on a hypothetical city, and Canadian Natural gave us 2 use case problem statements on tailings treatment and bitumen viscosity for transportation. It was interesting enough, the motivation for participating in the challenge for the 2 companies were different. For ACCO, it was the journey. They wanted to sort of experience the experimentation of quantum. They wanted to even how to put a problem into a quantum relevant quantum problem statement, and also go through the process with us, with our SIR, and even learn how to assess a potential quantum solution. Whereas for Canadian Natural, their motivation was solution. These are the problems they have been trying to solve for a long time, and it was very costly. So for their point, it's like, I'll try anything. If this can solve, even if it lead to 1% improvement over the classical solution, I'll be interested. Let's try it out. So the winners were unveiled at our annual summit, QConnect, in 2023. And they were Angel Q, which is a startup in Singapore, and Accenture, which is a global consultancy firm. So after the winners were announced, we're hoping to have some follow-on projects, but nothing formalized yet. Another initiative that we launched recently is the membership program. So our membership program offers access to, or priority access to resources and insights and expertise to help you stay at the forefront of quantum advancements. So number 1, priority access to our events that we'll be hosting, especially at Q Hub, including QConnect 2025, which I'll talk about later. Number 2, priority access to road mapping services. So essentially, this is a collaboration with our SIR. So we have SIR, of course, in quantum algorithm, Adam here, but we also have SIR in quantum sensing, and also quantum safe communications. So these services are just to work with our SIR and quantum experts that we have access to design customized quantum integration strategies specific to your organization. And number 3, member will have priority access to our solutions lab, which I'll talk about in the next slide, and access to our community reports. So stay informed with newest trends and the news in quantum. All right, and we have wonderful advisory committee to kind of, guide us along the way, just to make sure we are creating a membership program that provide value to the industry and the solution adopters that we are hoping to serve. So David, thank you very much for agreeing to be our advisor. And the Solutions Lab, so our Quantum City Solutions Lab is the motivation is to, number one, drive innovation, number two, empower startups, and number three, to collaborate with industry. So our goal is to accelerate the development of quantum solutions by connecting the industry with innovators to solve real-world challenges. So it bridges cutting-edge research and practical applications, again, driving innovation and growth. And Solutions Lab is supported by Alberta Innovates. So that you might think, okay, so you're working with industry, you want to solve the problem, but where is the innovation coming from? If you're creating all these demand, essentially, where's the supply coming from? And of course, the innovation and IP comes from the university many times, but often really innovation comes from startups. And quantum is so new, we can't just focus on Alberta only or Canadian only startup. We wanted to have access to startups from around the world. So in fact, I think stats is kind of vary depending on where you read, but I think 70% of the startups, quantum startups, were created in the last 3 years, and there are about 350 startups. So it's a really new sector, and quantum is not developed just in our backyard. It's really being developed everywhere. So we wanted to have a really great deal flow from all around the world. So we partner with QAI Ventures, which is a Basel-based quantum-specific venture fund. And they've opened up their Canadian office, or North American office in Calgary. So they've chosen us, their first outside of Switzerland, outside of Europe office. And they'll be running their accelerator program in March of next year, housed in our collision space Q Hub. So David, in the back here, he's the head of the accelerator. Yeah, that David. He's the head of the accelerator. So we'll be seeing 5 to 10 startups from around the world going through the accelerator program here in Calgary. And just the final slide on Q Connect. So this is our annual event. Really, we started this event because we were getting questions from industry. Okay, I don't want to go to a scientific conference because I'm not a scientist, but I want to know about the use cases, meet potential users or startups, or just even find out what others are doing. And we couldn't really find an event that we liked enough to recommend. And naively, sure, I can have an event. How hard could it be? Don't do it. But it's been a great experience. It's been, we've been getting overwhelmingly positive feedback. So this was our second year hosting, and of course we'll have Q Connect 2025 next year in November. So we typically see about 300 attendees from really around the world. This year we had more international attendees than last year. We had one from Japan, we had Korea delegation, that we had European delegation. So it's becoming really international. And so this year's our major panels were quantum and human health, quantum and sustainable cities, and quantum and modern energy. So I highly recommend that you come check us out next year in November, Q Connect 2025, which is the year of quantum, by the way. So that's it. If you have any questions, I'll be happy to answer. But I strongly recommend that you follow us on LinkedIn. That's where we put all our events and our news. So happy to answer any questions from here. Thank you. Done such a great job. There's no question.
You can keep this one. I'll see this one. Are there any questions? I have a question.
Yes.
So the city of Calgary or other municipalities as well are probably a source of use cases, all different types of optimization use cases.
Absolutely.
How would we engage with you to unravel these use cases and submit them as potential ways for your experts to look at?
Very good question. So I would say first point of contact should be either Ryan, our industry engagement manager, or our scientist residence, Adam. And so I can go back to the program we talked about, the Solutions Lab or the use case development. So that's sort of a program that I can think of ways to engage folks like City of Calgary with, like beautiful use cases of holders here. So yeah, so I would say talking to these two would be the best way to do it. I think for Solutions Lab, we are thinking about having an online portal so you can submit a question. I don't know if that's up yet, no, but Soon it will be up on our website where you can submit potential use cases that you want to explore. Then, yeah, we'll be happy to work with you.
Okay, thank you.
Thank you.
Questions?
Oh, okay.
Give me a second, Ann.
Okay. I think mine is somewhat like Dave's, but a little bit different. So you were talking about your scientists in residence and everything like that. So if a person has an idea and they come to you and they're like, I have an idea, but I think that it's going to need some sort of quantum capabilities. Is that how it starts? Like, is that the workflow that a person would go through? They just come to you, say this, and then they just get paired, or what does that process look like?
Yeah, so actually often when we even hear about our use cases, I think Adam can correct me if I'm wrong, many of the cases they're like, I don't even know if it's quantum relevant. Mm-hmm. And we'll be able to help you whether if it's quantum relevant or not, and if it is. Sort of just like what we did with ACCO and CNRL. We took their challenges and turned it into a quantum relevant problem statement, which is an extremely difficult thing to do, and not a lot of experts can do that actually in the world. So that's something we're building internally so we can help the industry. But yeah, definitely we get the question a lot. I'm like, I've got this problem, maybe it's quantum, maybe not. So we're here to help you. Yeah.
So that first stage would be like a discovery that's all about like problem definition. Yeah. And then after that, you
that's
might,
right.
Okay,
yeah.
That's awesome. Thank you.
Did you want to add something, Adam? No, okay. Oh, question here?
Oh. Yeah. Hey, Sandra. Here. I'll give you this.
That was a very enlightening presentation.
Okay, thank you.
Thank you. You mentioned ATCO and CNRL. Now, were those problem statements, were they able to be solved? And were they also able to be put into application?
Very good question. Adam, you gonna take this one?
Sure. We'll probably say the same thing, but I'll grab it. Okay, in a word, no. But that's not to be pessimistic. I mean, that's not me being negative. So, okay, were they solved? Yes. From earlier at lunch, the state of quantum computers and the state of quantum technology is such that the sort of problems that you can solve right now on quantum computers, it's very hard to get a problem that's big enough that it competes with like utility scale solutions that are already out there. So what we saw in the solutions that we got was not, we're doing better than the best classical solution right now using the best classical technology. We saw an indication that something interesting is happening. That means that as quantum computers get better, this is an interesting question to revisit, an interesting problem to revisit. So there were positive results, but they weren't, let's deploy this today. They were, let's wait and see, let's keep up to date on quantum technology. Let's revisit it in a year and see what happens. Yeah.
So then now, are you going back to a classical solution?
Yeah, so I mean, I'll talk about the ATCO one just because it's maybe a little easier to describe. So that was a question about how you scheduling charging for electric cars in a hypothetical future city. So already the problem was hypothetical. If you had to solve that problem right now, your best bet would still be to use a classical computer and state-of-the-art classical techniques. Now, in a couple of years, as quantum technology gets better, is it going to start outperforming those state-of-the-art classical solutions? Maybe. And we sort of, the result of the ATCO challenge was we have an idea of the algorithm we would want to run and want to try in another year or in another 2 years. So, yes, and this is not, I should say, unique to this challenge. This is quite often the state of quantum these days. You see promise and you see potential, but in a horse race against the very best classical technique, you're maybe not beating it yet.
So essentially, from what I'm understanding, is that the problem needed to be more complex.
Yeah, and the hardware needed to be better. So there's a limitation just in terms of the quality of the quantum computers that were built and that we had access to. And already we have better quantum computers, just better machines than what state-of-the-art solutions could use for this challenge. I mean, this challenge was a year ago, and that's already pretty out of date in terms of technology. So I would be interested in rerunning exactly the same solution on a state-of-the-art quantum machine today and seeing how it does. But yeah, going into the challenge, looking at sort of the quantum computers that teams were getting access to, and keeping in mind that using the very cutting edge is very expensive, and for a challenge like this, you have to stay a step back from the cutting edge, just because you want it to be global. You want lots of people to be able to try it. The target was never to beat state-of-the-art classical, but it was to show an idea that looks like it has promise, and that's sort of what we got out of that challenge. If that makes sense.
I'll just add one thing though. So, did this challenge solution impact their share price? No. But I think for industry that we work with currently, they also see it as an sort of a attraction of a new workforce tool. So number one, it will take time to train the workforce or even to figure out a problem statement that is quantum relevant or they want to try it out. It's kind of like a Y2K, right? It's not gonna be done overnight. It takes time to find the right use case, train your workforce, and essentially they also cite it as a way to engage a current workforce or attract new engineers to the company. So that's another, maybe not primary motivation for doing it, but that was a secondary motivation doing it.
Okay, any other question?
Yes.
Yeah, go ahead.
A follow-up question.
Can you provide an example where quantum computing was able to provide a solution to a very complex problem, a use case for that?
Like the chemistry problem, or?
Yeah, or the last mile logistics.
Okay. Yeah, go ahead.
Wasn't there one on protein folding?
Yeah, okay, yeah. Sorry, yes. Yeah, okay, no, it's a great question.
Great, I call a friend and he just shows up.
I feel bad, I'm taking over your presentation. No, okay, it's a great question. It's a great question, and the answer is more nuanced than I would like it to be. There are cases where quantum computers are being used right now at the industry scale. The Port of San Francisco, the San Francisco Port Authority uses a quantum computer to schedule loading and unloading. Last mile food delivery, I think with Pattison Food Group is another one. Both of these use a D-Wave quantum computer. And so these are examples where quantum computer is seeing commercial use. Now, when you ask me this question as a scientist, there's another question, which is this quantum computer really doing better than the very best classical solution you could have come up with for this problem? Now, that's not the metric you need to beat, to see it used in industry. If it's seeing commercial use, that's great. Would I point to that as an example where a quantum computer we know is outperforming the very best classical solution possible? I'd be hesitant to point to that. And I think, we talk sort of about the killer app for a quantum computer, the one that's obviously outperforming anything you can do classically. And we haven't seen that yet. But that's a very high bar, right? It's like saying, not only bring a solution to market, prove that it's better than absolutely every solution out there. That is the standard that we haven't hit yet, but we think quantum computers will hit one day. But we're seeing these commercial applications. There's Megan mentioned protein folding, and we've got ideas a lot to do with sort of simulating chemistry or simulating quantum physics, simulating nature, where we think quantum computers will be able to do things that no classical computer can do, but that requires the hardware to be better. And we just haven't hit that level of hardware yet. So nuanced answer, but hopefully that, yeah.
So what is it better?
Yeah, I love this question. Yeah. In a word, okay, in 2 words, noise and size. So size refers to how big, literally how many ones and zeros you can squish on your machine. How many you put in, how many you get out. The computers we have right now are limited in size. So yeah, so I mean, just the type of problems you can solve just aren't that big, like most commercial scale problems need a lot of ones and zeros because you're thinking about a very large system. D-Wave is actually a machine that's fairly large, but most of our quantum computers are fairly limited in size. The other sort of subtler issue is one of noise. So inside your quantum computer, you have a bunch of operations that are going on. Every time noise means that you try and implement an operation and you get something a little different. So, you try and add 2 numbers together and you get it right 90% of the time, but 10% of the time you get the wrong answer. Now, the problem with this noise is that as your computation gets longer and more complex, these errors accumulate. And so when you have noise, you're limited in the sort of computations you can do, because if a computation is too long, you see more and more errors and it just ruins the output. So lots of the potential killer apps for quantum computing are very subtle, are very delicate. And so even one error along this pipeline will completely kill your result. We have other apps that are more robust, other ideas that are more robust. Those are the ones that we're trying right now and using right now. But these sort of, the more delicate ideas, we just can't run right now on a quantum computer because of errors, because of noise.
Thank you, Adam.
Oh, yeah. I'll talk to Cubo and see if they can add it to the quiz. Okay. Don't let me stand back up again.
I have another question. Okay, so let's say we come to you guys with a number of different challenges. What's your capacity in terms of intake? How many, or what would you expect you'll be able to take in for challenges or problems to solve? And what's your capacity in terms of intellectual capacity? How many experts do you have that you can throw at a problem?
That's a very complicated question. I would say simple way to answer is that, so we're not the one who's often creating the solution, right? So like all the activity will be guided by our SIR, our scientific director, but we would want to engage essentially the owners of the data from the challenge sponsor, but also we will want to bring in trainees as interns into the project. So it's not just like, we only do one project at a time, because essentially we can create a pods of, working group depending on how many challenges we have going on. And then the question is like, what's the maximum number of challenges we can take on at the same time? That's a good question. I don't think we've stress tested that yet. I would say we have capacity, as in funding. We have capacity to do like 6 to 7 challenges at the moment. That's funded by Alberta Innovates. But
okay.
Yeah, so I would say maybe 3 is a good number to start with. But to be honest with you, I don't think we've stress tested that yet.
Okay, good. Thanks. Any other questions? Okay, well, thank you very much, Megan. That was excellent.